Good morning. Welcome to the first session of Computer Organization and Architecture. I am Priyanka KODURU, Assistant Professor in the Department of Computer Science and Engineering, KMIT. Let us start the session. First, we'll see the course objectives. So, what are the objectives of learning this course, Computer Organization and Architecture? So, it helps you to understand the basic components of a computer and also understand the various addressing modes, instruction sets, and instruction formats. And it also helps you to understand and manipulate the numbers which are being stored in a digital computer. So, moreover, you can also explore the organization of a memory and input output organization. It also helps you to understand the concept of pipelining techniques, which is required for the execution of the instructions. Next, coming to the course outcomes, at the end of the course, what is that you are going to, what is the outcome of your particular course? What is that you are able to understand? So it helps you to, at the end of the course, you can be able to understand the basics of the instruction sets and what is their impact on the design of a processor. And moreover, you can also have an understanding on the different types of functional units present in a digital computer, and you can recognize the number systems, and you can also perform the various types of arithmetic operations on the number systems, which are numbers which are being stored in a digital computer. And you can also evaluate the cost and performance analysis and design trade-offs in designing the computer. And it also helps you to design a pipeline which is required for the consistent execution of instructions with minimal hazards. So these are the outcomes of your course. So coming to the syllabus, we have 5 units of syllabus. So the first unit, the part one of first unit deals with the introduction to the digital computers, where you're going to learn about what is the introduction to your computers and what is a block diagram of a digital computer. Next, you are also going to identify the difference between the computer organization and computer architecture. Next, coming to the second part, the basic computer organization and design. Here, we're going to talk about the common bus system and bus and memory transfer, and what are the different types of registers present in a computer, the computer registers. And we'll also see about instruction codes, and then different types of computer instructions. There are three types: the memory reference instructions, register reference instructions, and input output instructions. Next, we move on to timing and control unit, control of a computer, and instruction cycle and interrupt cycle. Next, moving on to unit 2, it contains information about the instruction set architectures. So here we are going to learn about general register organization and about the different types of instruction formats with examples, as well as the different types of addressing modes available with examples. And then we are also going to study about the data transfer instructions, data manipulation instructions, as well as the program control instructions. Next, coming to unit 3, it contains two parts. Where the first part mainly deals with the representation of the data which is being stored in your computer. What are the different types of data types? What do you mean by complement, one's complement and two's complements? Next, how do you represent the data in the form of a fixed point representation and a floating point representation? Next, we're coming to a second part which deals with arithmetic, where you're going to perform different types of arithmetic operations on the data, such as addition, subtraction, multiplication, and division. Next, coming to unit 4, the memory architecture, it deals with the memory architecture. So, the memory hierarchy. So, here we are going to talk about the memory hierarchy, the main memory, auxiliary memory, then next different types of memories like auxiliary memory, associative memory, cache memory. And then we are also going to discuss about the different types of memory mapping techniques like associative mapping, direct mapping, and set associative mapping. Next, second part deals with input output organization. So here we are going to talk about input output interface, asynchronous data transfer, modes of transfer, and priority interrupts, and direct memory access. Moving on to Unit 5, we are going to discuss the overview of pipelining technique and processor architecture. So, here we are going to discuss about parallel processing and how the pipelining technique helps in parallel processing of instructions. So, here there are different types of pipelines like arithmetic pipeline, instruction pipeline, and risk pipelines. And next, moving on, we discuss about the design issues or hazard situations which occurs in the execution of instructions in a pipeline. So we are going to talk about the structural hazards, data hazards, and control hazards. And we are also going to discuss about the branch prediction techniques like static branch prediction and dynamic branch prediction. Then next, moving on to the processor architecture, there are two types of architectures like CISC and RISC. So we are going to see the characteristics of RISC and CISC as well as the differences between the RISC and CISC. Next, coming to our textbooks, we have a prescribed textbook, which is a very good book, Morris Mano, third edition. Computer System Architecture by Morris Mano. Coming to reference books, we have Carl Hamacher, Computer Organization by Carl Hamacher, 5th edition. And mathematical concepts, arithmetic part, you can refer discrete and combinatorial maths by Grimaldi. So this is about the books. Next, we will start with the session. Today's session, we are going to discuss about the introduction to a computer and its block diagram. Coming to an introduction, so the word computer comes from a Latin word which is called as a computer. So which means to calculate, to count, to think, or to sum up. So the word computer means a device that performs computation. So more overall, it is an electronic device that processes the raw data based on the instructions which are given by the user. So, a computer is an electronic device that performs a variety of tasks such as storing, processing, and outputting the data. Next, coming to the functions of the computer, it is responsible for four functions like input, storage, processing, and output. As a part of the input, it accepts the data or instructions through the input devices from the user. As a part of storage, it stores the data which is required for the future use. As a part of processing, it processes the data based on the instructions which are given by the user. As a part of an output, it produces a result. These are the main functions of a computer. Next, coming to the block diagram of a computer, a digital computer is a fast electronic calculating machine which accepts digitalized input information and it processes it according to the instructions which are stored internally and it produces the resulting output. So, if you see the block diagram of a digital computer, it mainly contains three parts: the input unit, CPU, and output unit. So, each and every unit is responsible for certain functionality. So, the input unit is responsible for receiving the input data from the user by means of input devices. And the CPU takes the input from the user and process it the data as well as the instructions which are being given by the user. So moreover, CPU is also called as the brain of a computer. And coming to the output unit, it displays the output results to the particular user, to the end user. Next, coming to the input unit, the functions of an input unit is to convert the input data into binary code. So here, the data which is taken as an input from the user, it is in the human readable form, like your normal characters or alphabets. So, but as a computer, the computer can only understand the data which is in a binary code in the form of zeros and ones. So, the main role of an input unit or a function is to convert that particular human readable code into a machine code or a binary code. That is done by means of an input unit. And it sends the particular data which is taken as an input from the user to the computer memory. The data transfer is one more function. So these are the list of input-output devices that are present through which the user gives an input to the computer. It can be a keyboard keyboard, it can be a microphone, it can be a mouse or trackball, anything. These are the list of input-output devices. Sorry, input devices. Next is the central processing unit. So the central processing unit or a CPU, it is also called as a brain of a computer. So the functions of the CPU is to control all the hardware and software, as well as to control the flow of data. And it also performs operations, all the operations based on the instructions given by the user. And it accepts the data from the input devices and sends that particular data. Uh, uh, it accepts the data from input devices as well as it sends the information to the output devices. Data transfer. And it executes as a part of program execution, it executes the programs which are being stored in the memory. And as a part of data storage, it stores the data whether temporarily or permanently. And arithmetic logic unit, it performs arithmetic and logical operations. These are the main functions of your CPU. So CPU, it is again classified into three parts. If you see, it is divided into three parts called the arithmetic logic unit or ALU, the control unit, and the memory unit. So it is classified into control unit, arithmetic and logic unit, and memory unit. As a control unit, it manages the computer components, interprets the instructions, and activates the other parts. So, as a part of arithmetic logic unit, it performs arithmetic operations as well as a logical operations. So, arithmetic operations like plus, minus, into, divided by, whereas the logical operations like greater than, less than or equal to, and greater than or equal to. Memory unit, it stores the data in instructions temporarily or permanently. So, we'll see in detail the control unit. The control unit manages the computer components. So it reads the instructions from the memory, interprets them, and sends the signal to activate the other parts of the computer. So based on the instructions which are being stored in the memory unit of the computer, the control unit is going to understand or interpret the information present in the instructions and understand what the operation has to take place. And based on that, it sends the signals to all other parts to perform that particular operation. And it controls and coordinates the input output memory as well as the other units of the computer. So this control unit is mainly responsible for providing a coordination between all the parts of the computer for the smooth execution of your user programs or instructions given by the user. Next comes arithmetic and logic unit. It performs basic arithmetic operations like addition, subtraction, multiplication, and division. And it also handles logical operations like greater than, less than or equal to, or greater than or equal. Next part, important unit of your CPU is the memory unit. So the memory unit of a computer is used to store the data and instructions before and after processing. So once a user gives the input data and instructions that need to be processed, that are first being stored in the memory unit, they're being processed or executed by the CPU. And once the execution is over, the results are again being stored in the memory unit before giving it as an output to the user. So it is responsible to store the data and instructions before processing and after processing. And memory unit is classified into two parts: the primary memory or a main memory, and the secondary memory. So if you see here, the memory, it is divided into primary and secondary memory. The example of primary memory are your RAM, random access memory, and read-only memory. And examples of secondary storage devices or secondary memory are the hard disks, compact disks, DVDs, and floppy disks. So, what is the difference between the primary memory and secondary memory? So, there are two types of memories present in the computer. The first is the primary memory. So, the primary memory is also called as internal memory or main memory or volatile memory. So, this is one of the computer memory that is accessed first or processor or a computer. Here the processor means the CPU. So whenever a CPU wants to execute a particular instruction, whatever instruction that is stored in the memory, it has to be present in the primary memory. The primary memory, so that because the CPU can only access the primary memory directly, it cannot access the secondary memory. So in order to execute a particular instruction, it has to reside in the primary memory. And the reason why we call this primary memory as a volatile memory is the data is stored temporarily in this memory. You cannot store the data permanently in the primary memory. So once the power is switched off, data will be completely erased. So it is called as a volatile memory. Example of a primary memory is your random access memory. Next, coming to a secondary memory, it is also called as non-volatile memory. Why we call it as a non-volatile memory is because it stores your data as well as your programs permanently, even when the computer or power is turned off. That is the reason we call this memory as a non-volatile memory. It is non-volatile in nature. So it is also known as auxiliary memory or external memory or even non-volatile memory. And examples of secondary storage devices or secondary memory are your hard disk, your compact disk, flash drive, or pen drive. These are the examples of secondary storage devices. Next comes the output unit, which is on the last, according to the block diagram. Then the third one is the output unit. So the output unit of a computer. The function of an output unit is to accept the data from the computer memory. So the results of processing, the results are stored back into the memory unit. So it takes or accepts the data which is stored in the memory unit of a computer. And we already know that whatever data that is present in the computer, it is in a binary code. So the output will be obviously be in a binary code. So, but the user cannot understand the binary coded information if you give it as an output. So the data conversion is done by the output unit. It converts that output, which is in a binary coded form, into a human readable language before giving it as an output to the user through the output unit. So it converts the binary coded information into a human readable language. That is also one more function of the output unit. So the functions of the output unit are it converts a binary coded information into human readable language or inputted language, and it accepts the data or information from the main memory of your computer. So coming to the examples of output devices through which the user gets the output from the computer: the speaker, headphones, monitor, printer, projectors, plotters. So these are the different types of output devices available in your computer. So you can see in detail about the different types of output devices: the touch screens, monitors, speakers, projectors, sound cards, headphones. So all these are some of the list of output devices available. Thank you.